So you'll notice the change in our directions to that is that it'll say today, find all zeros. And so no longer will we throw things out if they are imaginary or ugly or anything like that, is that we do include all of our zeros as we go. The other part that gets a little bit challenging is when I handed you a polynomial before and I said find the zeros, pretty much we had one of two methods. We either were able to factor it through a variety of options, just factoring, factor by grouping, sometimes it was a GCF, or maybe it was an ugly quadratic and we had to do quadratic formula. We spent a day on that. But today, I'm going to hand you, and it may not even be a quadratic, it could be just any old polynomial. We have to find the zeros of it, and it's not factorable. So guys, understand that what we're learning today is kind of our last resort. I can't factor it using any of my numerous methods to factor. We resort to this rational zeros theorem. And the rational zeros theorem says that if a polynomial has zeros that are rational, what does rational mean? Can be a whole number, can be a fraction. Anything that can be written as a fraction is something that's considered rational. Is of the format plus or minus p over q. This little phrase right here, plus or minus p over q, is going to be the phrase I use to prompt you to think of this list anytime after this that you need to think of this list. So how do we make that list? P is going to represent all the factors of the constant. So if we use this polynomial as kind of our example here, that would be all the factors of 12. The top of the fraction would be all the factors of 12. The bottom of the fraction is all the factors of the leading coefficient. So the number in front of our leading first term becomes all of the numbers we will use for Q. To start today, we are just going to create this list, and this list is when you are asked to find all of your, this is the phrase, possible rational zeros. This is not necessarily all the zeros. They won't all work, but if it's going to work, it's going to be on this list of numbers, is basically what it's saying. Okay, so it's giving us some options, try them out. So when you are asked to find these possible rational zeros, again, we're going to make this fraction p's over q's, p's being all of the factors of 12. 1, 2, 3, 4, 6, 12, over factors of 1, which is 1. Now, I get the whole shortcutting things, but when you write out this list for my eyes, like on a quiz or a test, we want to make sure that we include that plus or minus on every number, because remember, that really is two numbers, the positive version of that number and the negative version of that number. So what I do is I write out the list of the constants factors. I do it one time each for every factor of that leading coefficient. So I would put all of these numbers over 1, and then I would start over all of those numbers over if there was a second factor over here. So we just keep repeating that list over each set of factors that's over there. Now we only have the factor of 1 is 1. So as I write each of those over 1, now 1 over 1 is not going to change. Anything over 1 doesn't change. So it's going to look like that's not there, but it is over 1, right? Plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12 would be our full list of possible rational zeros of that polynomial. There are no other whole numbers or fractions that will be zeros of that polynomial because they are not on that list. Okay? So the second one gives us a little bit more of an example here. Again, looking at our factors here, 1, 3, and 9. Over 1 and 2. So this one gives us a second factor for that first term. You take the factors of your constant and you write out that entire list over 1, and then you repeat that entire list over 2. So plus or minus, and the first time I write it, it's over 1, so nothing's going to change. 1, 3, plus or minus 9. And then I repeat those three numbers all over 2, plus or minus 1/2, plus or minus 3/2, plus or minus 9/2. Now, we didn't see any of this happen, but if any of those fractions that I just created needed to simplify, we would simplify. If they simplify down to something already on our list, we don't include it a second time. So, for example, if we had like the number 6/2, that would simplify down to 3, and we already had 3 on our list, so we would just not write it because it would be something that was already on our list. Okay? Possible rational zeros. Questions? That's where these start. That just gives us, it basically is giving us a word bank. They say, okay, try these out. That's your word bank. It's going to be from one of those. Pick that. I'm going to give us some options on our calculator to help us speed up our process. But this is how we use them. Now, this seems like a lot of steps. I get it. Guys, we only use these steps if the other options we have fail. I can't factor it using my numerous ways of factoring it. I have to go to this. And so when I've tried factoring first, and it doesn't work, I go to finding my rational roots. So finding P over Q is what we just learned how to do on that page before this. Make my list of factors of the constant over factors of that leading coefficient. After that, we're going to test each of those options in our calculator until we get a 0. Now, there are going to be different ways of doing this, whether this is a graphing calculator type question. I'm going to give you some options. If it's not a graphing calculator type question, it's the same idea though, and that idea is we are plugging in those 0 options, and we are looking for one that equals 0 when I plug it in. Now, with our graphing calculator, we can plug them in a lot faster. If I don't have my graphing calculator, I might have to either mentally plug them in, try them out with synthetic division, or scientific calculator, whatever it is, but I'm still looking for an answer of 0. Because if it's an answer of 0, it works. When I finally find one that works, we're going to use synthetic division to work our problem down to something factorable. Now, these last two steps, we can kind of adjust the wording a little bit. It says we have to get down to a quadratic or a trinomial. That's not necessarily true. We could actually get down to something factorable that's 4 terms if it's factorable by grouping. If I know more zeros than that, I can keep going past a trinomial. I can work it down to a linear, and then I don't have to factor at the end. So that's a little bit of, yeah, we would have to simplify a little bit. But basically what this is work this down as far as you can. When you get down to the end, you're going to set whatever is left over, whether that is a trinomial or something more or less than that. Whatever is left over, we are going to set equal to 0 and solve for x. Okay, that's pretty much the general rule on all of these anyway. And those will give us our zeros at the end. Questions? All right, does anyone still need this page? So let's see this in action. The first couple are kind of similar, but it's going to give us some options of things that we can do on our calculator. Now, here's the deal, is I'm going to show you today some options that we can use on our graphing calculator and use them. However, you do not always get your graphing calculator. So please understand that sometimes you have to go the long route, and that would be using my scientific calculator or my brain to plug these in, right? So sometimes that's our option. Now, before we start, it does say find all zeros. Try to factor, but this is not an x squared, so be careful. This is not factorable. If that was an x squared, it is. It's not an x squared. So when it is not factorable, that's when we have to think through our list of possible rational zeros. And again, this is creating a word bank for me of what I can use to try out. So let's look at our possible rational zeros here. Again, that's going to be our p over q's, plus or minus p over q. P is the factors of 2, which would be 1 and 2. Q is our factors of our leading coefficient, which would just be 1. So a pretty short list this time, right? Plus or minus 1, plus or minus 2. So if it is a rational zero, it is going to come from that list. Now let's talk about how we can speed up our process a little bit here. Grab your graphing calculators. Type that function into y1. X cubed minus 3x plus 2. All right, guys, we found several options of how to find things like zeros, right? That's what we're looking for right now. We're finding zeros. One of those is I could find an appropriate window and use that zero function to find where it hits my x-axis, right? Those are zeros. I do think that one takes a little bit longer, so here's another option. My calculator will plug things in for me, and I want it to plug in like 1 and -1, 2 and -2, and it can do a whole bunch of those all at one time using the table. And we've looked at that a little bit this year, but just a reminder to check your table. You don't have to do this part very often, but if you guys will hit second window above it where it says table set, just make sure that your delta table is set to 1, and that means it's plugging in things in increments of 1. Where it says table start, that doesn't really matter. If you're like way away from 0, like out at like 35 or something, you might want to put that back closer to 0. But once you're there, you can arrow up and down and check whatever numbers you want. And you want it to auto independent and dependent variables on that, okay? You don't need to check that every time, but if your table gets messed up, that's where we fix it. So if I go to second graph or second table, I can kind of scan up and down here, and I'm looking specifically at those 4 numbers, because if there's going to be a 0, it's going to be at one of those 4 numbers. And I'm looking for any of them that give me an answer of 0, because my table is plugging all these numbers into the function, giving me the answers when it does, and I can see that there's a 0 right here at -2, and then there's a 0 right there at +1. Those are zeros that will work in my synthetic division. Those are zeros of my polynomial. So if I come back over here, the zeros of this function I just saw on my table are going to be -2 and +1, right? I'm remembering that correctly. -2 and +1. So what I need to do, that's not all of the zeros, is I'm going to go to my synthetic division, remembering to replace any missing terms with a 0. And we haven't talked about this, we will talk about this in a couple days, is that we really will get as many zeros as our biggest exponent. And how we get there is a little different per problem, but we should have 3 zeros when all is said and done. Use the zeros that they said will work, -2 and +1, in my synthetic division. I have to, because it's going to work my problem down to something else I can either factor or set equal to 0 and solve. So let's see here. I know I should get a 0 at the end of this because those are zeros that work. And if I don't get a 0 at the end of my synthetic division, something went wrong. I knew that was going to work. I also know +1 is going to work, so I can do synthetic division a second time. And remember what I'm looking at here. So I did this 0 right here is -2. I did this 0 right here is +1. And what I'm left over with, remember, work your way backwards. Remainder, constant, x to the first. So this right here, I take my leftovers, and I set it equal to 0 and solve, and I get a 0 of x equals -1. But don't I already see that on my list? So how do I describe that? Multiplicity, right? We saw it twice. It has a multiplicity of 2. We tried it out once, and we got an answer of that once. So that's where our missing 0 is coming from. The fact that this happens twice, multiplicity of 2, which means it bounced at that. If I were to look at the picture, you would see it bounces off your x-axis. And your third 0 is at -2. So part of our missing zeros can come from multiplicities. Questions on that? Right. The only thing that might be is if this were, hypothetically speaking, a higher order, we know it would have an even multiplicity, not necessarily 2. On this one, I could have figured out 2 because we could only have a max of 3 zeros. Does that make sense? Okay. All right. Next one. P of x equals 2x cubed plus x squared minus 13x plus 6. I want you to attack this one very similarly to how we did the last one. I'm going to give us a little trick in our calculators at the end of this problem also to use. But again, not factorable. I've got 4 terms up there. I would have to factor by grouping if I were going to be able to factor this one. But it doesn't turn out the same as I take out the GCFs, right? So yes, always try factoring first. But if I group my first 2, group my last 2, which don't do this because it's not going to work, I would get 2x plus 1 and 13x minus 6. Okay, those don't match, which means it's actually not factorable, right? So I'd go back and I'd say, okay, well then my next option is to try out my list of possible rational zeros, which is my list of p's over q's. So from this list, factors of 6, 1, 2, 3, and 6 over factors of 2. So remember how we make this list. I'm going to write out 1, 2, 3, 6 over 1, and then I'm going to write out 1, 2, 3, 6 over 2. Now, this is what I said was going to happen here. When I'm writing out that list a second time over 2, I end up with 2 over 2, and 2 over 2 simplifies to 1. That's already on my list. I don't need to include it a second time. Same thing happens when I do 6 over 2. 6 over 2 simplifies to 3. 3 is already on my list. I don't need to list that a second time. So the fraction part of it, the over 2 part of it, added 1/2 and 3/2. I can still start this the same way. Now, guys, remember, I'm giving you these graphing calculator shortcuts, which are wonderful, and use them, but we do need to know that I might have to manually plug these in using a scientific calculator or my brain or synthetic division if I don't get a graphing calculator. So grab your graphing calculator, type that into your Y1, please, and find me a zero that's going to work. All right, who's got a 0 for me? What's something on our table that worked? What was it? -3? No? Yeah? Okay. And which one? 2? All right, we're going to talk options after this of some things that we can do to check out the 1/2 and the 3/2. -3 times 2, let's see, -6, -5. And again, I could stop at this point because this is a quadratic. I could stop and factor. However, I know another one that's going to work. So I could keep going, and that gets me down to a linear that's a little faster to solve. That's kind of up to you because ultimately I need the list of zeros. It doesn't really matter how I get there. Oops, 2 times 2 is 4. And again, that gets me down to a linear. 2x minus 1 equals 0. Add 1, divide by 2. I'd be looking at my last zero of 1/2. Now, there are a couple options that I could do. Some people say, can I go to the table and change it to check, like instead of stepping by 1, stepping by 1/2? Absolutely, you can do that. I might avoid that just because we can have, like, if the first number is a 4th, we could have halves and fourths, and that's a whole lot of numbers to scroll through. Okay, but you could do that. I want to show you a function on your calculator you may or may not have been introduced to before. I have mine typed into Y1. If I wanted to test this at different numbers, I don't have to type all that in. My calculator will do that for me, since you guys already have it in Y1. Find the button that says vars. If you hit vars, and arrow over to yvars and pick the function option. You can go pick whatever function you have that typed into. I have it typed into Y1, so I would pick Y1. If you happen to type yours into something else, pick wherever you typed it in. And then I can tell it to evaluate Y1 for any value that I want. Maybe I want it to test out 1/2 or -1/2. Now, I know 1/2 is one of my zeros. When I plug 1/2 into that function, I should get an answer of 0, right? So that's what I'm looking for here, and it tells me it's 0. If I wanted to try it out for something else. Now, those of you that have the newer operating systems, let's try to make that faster. Hit alpha, and I think it's trace. Alpha trace. Yep, there it is. Alpha trace, I can just pick option 1, and that will go get y1 again. If I test it out like -1/2, it shouldn't be 0 because -1/2 is not one of the zeros of this function. It should give me some other number besides 0, which it does. Tells me that's not a 0 of my function. Okay? So kind of some ways that you could test out or speed up things when they're fractions and I don't have it on my table. I could just try it out that way too. Just some options. Okay? And getting to know our calculators. All right. Let's continue on. Next one. This one I'm going to expect 4 answers when I'm done. X to the 4th minus x cubed minus 5x squared plus 3x plus 6. Again, I would always try factoring first, not factorable. So then I'm going to go to my list of possible rational zeros. If I have my graphing calculator, I'm going to just check those out. If I don't, I'm going to start plugging them in. Factors of 6 over factors of 1, which is just 1. That always makes our list a lot shorter. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay, so you guys are going to type that into your calculator. This one has 2 good things that we haven't seen yet that I want to make sure that we understand. But if you guys will go to your calculators, please, and find me an option that I can use to work this down. Who's got something for me that is working here? -1 and 2. Okay, so that's 2 out of our 4 answers. We now have to use synthetic division to work this down. It's starting at an x to the 4th. Okay, let's see. All right. I'm going to pause at this moment right here because typically we would say that I would keep going. This is an x cubed, right? But my people out there that have really good number sense, can you look at those 4 numbers, 1, -2, -3, and 6, and see that if I were to write that out as a polynomial, that it actually is factorable by grouping? If you have great number sense and you see that, if I were to group these 2 and group those 2, that I take out GCFs, and this, when I take out the GCF of 3, is going to end up being like an x minus 2, just like this is an x minus 2 when I take out the GCF. If you see that, you can always stop at that point and just factor to find the rest of your answers. And it's just usually a little bit faster and more direct. If you don't see that, we do have another option over there. And I can keep going with my synthetic division. That just means I have to do synthetic division again. This is another thing that I wanted us to see. Okay, so when I did synthetic division this next time, I end up with 1, 0, and -3. Writing that into my polynomial, remember this goes remainder, constant, x to the 1st, x squared. So you see how this is going to be an x squared minus 3. We all good with that? So this is something we haven't seen yet today. That is something I can solve. Add 3. Square root, and I just have to remember when I square root. Now, I can do the square root of +3, right? That's just a plain old ugly number, which is why you're not going to see that on your table, and you're not going to be able to find that perfectly on your graph because it comes out to an ugly decimal. But we're going to keep everything exact. We're not going to ever have decimals in this list. Plus or minus square root of 3 are your last 2 zeros, positive square root of 3 and negative square root of 3. Questions on that? All right, our last one of this type, nope, that's totally a lie. We have 2 more. on this last one's. Very similar in how they finish, with one small change between the two of them. Okay, so someone can get that quickly typed into their calculator and give me some options here. Again, we're going to look at our possible rational zeros. Factors of 5 over factors of 1 gives us a very short list to look at. I don't even need a graphing calculator to test these out. That's a short list. I absolutely could just try them out with my synthetic division or by plugging them in. When all's said and done, I'm going to expect 3 answers here. Somebody find me an answer. 1, okay? And we see at this point, 1 was the only one. If you type that into your calculator, 1 is the only one you're going to see on that table. And it's going to cross our axis 2 more times, actually, but it's ugly numbers. And so we're going to have to go to our algebra to figure out what those are exactly. So I'm going to write out my polynomial. And I can see that this is not factorable. That if I try to come up with factors of -5 that add up to 2, they don't exist. And so at this point, we have to rely on, OK, how else do I solve a quadratic formula, right? So I would go to my quadratic formula on this, which is why we practice our quadratic formula. But if you've forgotten, remember it's -b plus or minus square root of b squared minus 4 times a times c all over 2a. And cleaning that up, -2 plus or minus, and again, everything's going to be exact. And so I can use my calculator a little on this, but that would be like just to type this in, because if I type the radical in, it's going to give me a decimal. 2 squared is 4, plus 20 is 24. Biggest perfect square that goes into that would be like 4. And then remember to check all your outside numbers. 2, 2, and 2, all divisible by 2. So dividing each of those by 2, we'd end up with -1 plus or minus 1 square root of 6 over 1, which a couple of those we don't have to write. And that's your last 2 answers. Remember, that really is 2 answers, because it's -1 plus the square root of 6 is one of them, and then -1 minus the square root of 6 is the other. Questions on that? Okay, last variety. This goes to the top of the directions where it says all zeros. On this one, again, if somebody can get that typed in real quick, let's look at our options here. Plus or minus 1, plus or minus 7, and that's our only list here. If you have to just use a scientific calculator to try these out, always start with the small numbers. Usually in the first like 1, -1, 2, -2, somewhere in that early couple numbers, you're going to find something. -1. Okay. And we run into the exact same thing we just had. There's only one on our table. So what I have left, I have to go to my polynomial. It is not factorable. There are no factors of 7 that add up to 4. So then I have to go to my quadratic formula. -b plus or minus b squared minus 4 times a times c over 2a. And this is our last variety of this. And that is when I clean up the inside, 16 minus 28. 16 minus 28 is a negative number. And up until today, we talked about that negative number, but we said, oh, that's not real. And all of our directions said only to list the real zeros. Remember talking about this? Okay. But now it says all. So now we just don't cross it off because it's not real. We continue just finishing that out, which we've done before. Biggest perfect square that goes into 12 is 4. And remember, when we square root a negative, square root of 4 is 2, square root of that negative is I. And we just don't cross it off as not being real. because they're not asking us only for reals, they're asking us for all. So simplifying my outside numbers, all divisible by 2, I would end up with -2 plus or minus I square root of 3 over 1, which gives us all the rest of our zeros there. They're imaginary. And the thing about imaginary zeros, they're not going to hit your x-axis. Your calculator cannot find those for you, decimal or not, okay? Because they're not real. Questions? All right. The last one, guys, please put this one in your notes and make a really nice page. I will tell you right now, this test is hard. You've heard me say that. This is one of the test questions. When you do not know how to start this problem, you will lose a ton of points because you can't even get to the beginning part of it. This is a no calculator question. Do you see that at the top? So understand when you are looking at this that you will at best have a scientific calculator on this, and it is asking me to graph it. In order to graph it, I have to find its zeros. It is not factorable, and that's what you're going to want to do to start this, because every problem I would do, I would want to factor it first. But when it is not factorable, we have to go back to what we just learned how to do today, and that is to guess and check our P over Qs. Okay? So to start this problem, I would make my list of possible rational zeros. I don't get a calculator to test those out, so let's talk about options here. Factors of 15 would be 1, 3, 5, 15 over factors of 2. That's over 1. The other factors of 2 are 2. So that entire list again over 2. Now, especially because I don't get a calculator to help me with this, is that I would absolutely try out 1, -1, 3, -3, 5, -5 before I ever get into the fractions, because those are going to get uglier. Now, I like synthetic division. You can also just plug them in to the polynomial. It's kind of easy for me to do synthetic division because I can just go and erase each time, which you can too. If you like write lightly, just go back and erase it. Try again, but I'm just going to test them out. That's all I'm doing. I have no real other way to do this. The other thing I could do is go plug it in. Up to you how you want to attack it at this point, but we've got to either plug it in or test it out in our synthetic division. We need to find something that equals 0 at the end. Okay? So 1 times 2 is 2. That'd be -3. And I can see that this one right now is not heading in the right direction. That's not going to equal 0. So I erase. Try something else. -1. -1 times 2 is -2. -7, 7, -21. Okay, not equaling 0 again. So I keep going down my possible rational zeros list. 3. Nope. -3 would be -6. There it is. Okay. So you can see sometimes we just have to guess and check. And yeah, it took me a minute to get through those looking for an answer of 0 because I don't want to keep guessing and checking because I don't know if there are any other nice ones. I would stop. That's a quadratic. Write out your quadratic factor. Okay, I'm looking for my zeros here. This is where I need to know my method for factoring. Whatever my method is, I'm a guess and checker. You can be a slide and divide, although I wrote and divide on a lot of our quizzes, so we don't want to make sure that we're making mistakes there. But I need to factor this and set anything that has a 0 or anything that has an x equal to 0 to get the rest of my zeros. Add 1, divide by 2, I get 1/2. Add 5, I get 5, and my list of zeros is just that. 5, 1/2, and -3. There's my dots on my x-axis. And now we're back to the problem that we already know how to do. I've got my dots on my x-axis. Go back to your leading term. That's an odd positive. So it's going to increase as we move to the right. There's the ends of my graph. To save us some time here today, I'm not going to actually test out, but we would pick a number between these two, test it out. So test out like -1 or -2, pick a number here, 2, 3, 4, test it out, see where my graph goes, put those dots on my picture, and it would look something like that. No multiplicities other than 1, so cross through, cross through, cross through, draw in my graph. Any questions for me? All right, your guys' homework tonight is a worksheet